Hi everyone, I'm Tony from Hong Kong, the City University of Hong Kong. And today I would like to present FingerT9. That is a same-side hand text entry method that is using a thumb-to-finger interaction for typing in smartwatches. And first, for the introduction, smartwatches usually require input from both hands, and it is just hard to use while the non-wearing hand is not free. And this motivates us to explore one-hand text entry method. The method can allow text entry using only one hand, and that is the same side hand which wear the smartwatches. Besides, smartwatch text entry usually suffer from fat finger problem and occlusion problem, and we would also like to avoid them. There are various words that propose different text entry method on smartwatches. Some propose using a tool-based keyboard and with touch screen tapping, and other propose ambiguous text entry on smartwatches, which can reduce the number of keys of smartwatch keyboards and make the keyboard even invisible to reserve more space for application. However, this will require another hand for input, which are not suitable for some situation when one hand is occupied, such as when one hand is holding a train handle or carrying a bag. Besides, there are researchers exploring one-hand smartwatch interaction, but how they could support smartwatch text entry is still unexplored. So we propose FingerT9 to support same-side hand text entry for smartwatches, and we combine thumb-to-finger interaction and the T9 predictive typing method into smartwatches. So the user can touch on the finger segments with their thumb to enter text with only one hand. For the design and the implementation, T9 keyboard has been widely used in the feature phone, and people can write message with only 9 keys. Once the user are familiar with the layout, they can even type without looking at the keyboard. And we combine the traditional T9 keyboard and the thumb-to-finger interaction for smartwatches so that we map a T9 layout on the finger segment, so the user can just simply using their thumb to tap on the finger segment for typing a message. And there are a total of 11 keys mapping on the different finger segments, and 8 letter keys and 3 functional keys. The functional keys are mainly used for adding space, deleting a letter, and selecting a candidate of possible word. To decide the user preferred mapping between the T9 keyboard and the finger segment, we conduct a questionnaire survey on 3 possible layouts. Layout 1 starts from the possible thickness of index finger, and layout 2 starts from the possible thickness of ring finger, and the layout 3 starts from the distal thickness of the index finger. So we propose these 3 possible layouts, and we invite 22 participants who are all right-handed and all have experience with T9 input before. During the survey, we present the 3 layouts, and the participants were asked to perform thumb-to-finger touch with the 3 layouts to experience how typing with these 3 layouts like. And then the participants were asked to rate in a 5-point lighter scale for the ease of use and the ease of memorizing the layout. So 1 means it is very hard to use or memorize, and 5 means very easy to use or memorize. And here show the average score of each layout. Layout 1 was chosen because it's preserved to be significantly easier to use and easier to memorize. And participants found that Layout 1 had the same key arrangement as traditional T9 keyboard, which make it easier to use and to memorize. We then built a prototype which consists of a smartwatch that having 1.5-inch screen with 240 resolution. And we also use an array of thin film capacitive sensor attaching on finger segments. With Arduino Mega and the system communicate with the smartwatch through Wi-Fi, sending which letter keys and functional key are pressed. Although it may be easier to put on using a growth, but we choose to use the thin film capacitive sensor attaching on finger segment due to its high robustness and allowance of tactile groove, that is the skin sensation of finger without blocking by the growth. Here is a video that the user typed with FingerT9. User type letter by letter and a candidate list will update automatically. User tap select and then tap 2 to select the second candidate, and they can keep on typing and tap the space to select the first candidate as default. So for the evaluation, we focus on keyboard typing and conduct within subject control experiments to evaluate the performance of FingerT9. We compare a total of 3 methods. First is the FingerT9, and second is the tilt space method, and also the direct touch input. FingerT9 is our proposed method. It is a same-side hand text entry method, and user perform thumb to finger touch to type the word. Tilt space input is also a same-side hand text entry method, and it uses the wrist tilting angle to move a cursor in a round keyboard for typing letter and selecting candidate. And we compare FingerT9 and this tilt space input because both are same-side hand interaction. Direct touch is the most common text entry method, which user directly tap on the screen for typing, and it is not same-side hand interaction as it requires both hands to be used. And we hypothesize that users are more familiar with this method and would type faster than the other 2 methods, and we use this direct touch input as a baseline to compare with the other 2 methods. The 3 input methods were evaluated with 12 participants, and all participants are right-hand and have experience with T9 input. The evaluation was done in counterbalance order, and the participants were instructed to practice for 10 minutes before the task. And for the task, the user are asked to transcribe a total of 20 randomly chosen soft faces from the standard faces set of evaluating text entry. And they were asked to correct error immediately only if they realize there is an error occurred. And they were asked to proceed as quickly and as accurately as possible. They were then asked to answer another task load index questionnaire after the task. We compare the performance of the 3 typing methods and measure the word per minute, the error rate, and the efficiency as the measurement. Here is the evaluation result. It's shown that FingerT9 is significantly faster than tilt space input, although direct touch is fastest, but it required both hands to be used. There is no significant difference in terms of efficiency and the error rate between FingerT9 and direct touch. This shown that FingerT9 is potentially feasible for text entry on smartwatches, and FingerT9 could result in similar or even better than direct touch in terms of efficiency and the error rate. Here are the average NASA task load index score. The lower, the better. A tube-based input had the highest demand, while FingerT9 was significantly lower than tube-based input in physical demand, effort, and frustration. There was no significant difference between the task load of FingerT9 and direct touch. From the first evaluation, we found that the performance of FingerT9 improved over time. Therefore, we conduct another evaluation to study the learning curves of the two same-side hand methods, the FingerT9 and the tube-based method, and a 5-day user study was conducted. There are 4 participants, all right-handed, have no smartwatch experience, and had experience with T9 input. They follow the similar requirement as evaluation 1 and transcript 10 randomly chosen soft phrases per method per day. In the first 2 days, the hints label containing the letter hints which shown in the image was attached on the back of the finger segment. So during typing, when the participant are not sure which letter the finger segment are referred to, they can look at the hints label and to get which finger segment is the corresponding letter mapped to. And the participants were asked to remember the layout for both methods. And starting from day 3, the hints label were removed. Here shows the learning curve of the 2 methods. Overall, FingerT9 results in a higher text entry speed, lower error rate, and high efficiency than the tube-based method. And FingerT9 can achieve around 5.5 words per minute in day 5. The improvement of typing speed of FingerT9 is faster than that of tube-based input. We can see in day 1, there was no significant difference in the text entry speed, while in day 5, FingerT9 has significantly improved than the tube-based method. And here is a drop in day 3 for FingerT9 because the hints label were removed and the participant need to perform blind typing. Although it takes more time in day 3 for them to remember to do the task, but all the participants were able to memorize the keyboard layout. And in day 5, the highest performance that one participant can type with a speed of around 6.09 words per minute. For future work, it is worth to investigate same-side hand text entry in more deep and in specific content. For example, to study the performance in walking, standing, or the condition that a hand is holding something. And it is also good to investigate same-side hand typing with the dominant hand and the non-dominant hand. And it is possible to apply thumb-to-finger interaction to text entry of other languages, such as the Korean and the Japanese keyboard also have similar layout. And also for other typing methods, such as the stroke count method, which use only 5 keys for typing Chinese word, may be suitable for to use thumb-to-finger interaction for typing. And one of the limitations of thumb-to-finger interaction is that finger segments are not equally accessible. The segment near the fingertips, that is the these so fingernails are easier to touch than the segment near the palm, that is the proximal fingernails, due to the degree of freedom of the thumb. Okay. Besides, users need to remember and familiarize themselves with the keyboard layout. One future direction worth to explore would be to optimize the mapping between the keyboard and the finger segment. To conclude, we introduce FingerT9, a novel same-side hand text entry approach for smartwatch, and combine the traditional T9 keyboard and thumb-to-finger interaction. The two evaluations revealed that FingerT9 performed better than Tuesday input in text entry speed, error rate, efficiency, and learnability. Thank you. This is FingerT9, and I'm happy to take questions.
Alrighty, folks, if you have any questions, please come to the microphone and introduce yourself.
Hey, how's it going? Darcy Filippano, Google. I have a quick question. With your day 5 participants, did you see any of them take the device and actually 180 it on their wrist so that they could both see the tap targets and the screen at the same time?
Oh, yeah. To keep the evaluation consistent, we ask all the users to wear the watch and with their hand down, so they are not like looking on their finger segment and type. And we have, since usually the users are wearing the watch in like face down condition, but we also like simply evaluate the performance with typing with hand down or hand up condition, and it seems that typing with hand up condition is a little bit faster than the condition that with hand down. But we consider that we usually wear the watch with the hand and look at our hand in hand up position. So it is not a really good idea for the user to always like turn their watch to the other side.
Okay. Thank you.
Hi there, Scott McKenzie from York University. Really nice work. I'm wondering if because some of the areas are hard to touch, which was your second or third last slide, have you thought about using other ambiguous keyboards that don't require 9 keys? I mean, there's quite a bit of work on text entry on 4 keys, 5 keys, and with the hard to touch regions, it would seem to make a lot of sense to maybe use fewer keys, fewer regions on the fingers.
Yeah, thank you for the question. It is a really good idea to explore like other kind of ambiguous keyboard and the keyboard layout, but like with simply like choosing the T9 traditional keyboard layout is we find that user may be easier to memorize the layout. But like for the future, it is interesting to explore other kinds of layout, maybe with less key or like typing with other kind of gesture to assist the typing. Yeah.
Okay, thanks a lot.
Thank you.
Adam from Control Labs. This is fun work. Thanks.
Yeah.
2 short questions. You said all the participants were right-handed. I was wondering. I know you're focused on same side text entry, but I'm wondering if performance is much better with people's right hand. And second short question is, what's the baseline performance of T9 on a smartphone?
Okay. Like for thank you for the question. Like for the first question, like all the participants are right hand, and we ask them to wear the watch on the left hand to keep the evaluation consistent. And like mentioned in the future, it would be like good to explore like people with maybe with their dominant hand on the right hand or on the left hand. So it's worth to explore. And like for the second question, that
I was wondering what the performance on an actual smartphone
the performance of the feature phone, like the one with physical button on, it can achieve like around 10 to 11 words per minute, but it requires two hands to be used. Yeah.
Nice talk, thank you.
Yeah.
Trying to shorten it. How much were people looking? Can you use it unsighted?
Like,
What performance do people achieve without looking at the watch at all?
actually, the method allows the user to type without looking at the watch once they are familiar with the layout. But one problem is that while they are doing the typing, there is a candidate list to assist them to select the possible word. But if they are like blind typing, they cannot look at the candidate list and maybe a little bit slower in the typing performance.
Yeah, I'm a cyclist, and it'd be fantastic for navigation, for typing in locations. And that'd be great,
Yeah,
but
it's thank you.
So we need to swap over now. Can we get
The last question, is it okay?
If we could, do you want to pull your laptop
I'm
out?
Yuri Vasilkiv from University of Manitoba. So seeing this just came to my mind. The first thing, how about thumb fatigue? Like, is it tiring for people to do that? How long they can do that?
You mean like how?
Yeah, fatigue.
Fatigue,
aspect.
or like so like usually like for the T9 typing, we do not expect the user to use this for typing a very long message. Maybe they saw the message in the smartwatch and just type only a few words, and they will not always like keep typing. So it won't cause really fatigue during the typing.